Deep inside a radio observatory in the quiet outback of Australia, a massive dish points silently at the night sky. Right now, on a screen in a dark room, a single blip of invisible light flashes for a tiny fraction of a second. It lasts less than 5 milliseconds, carrying more energy than our sun produces in 3 full days. Before anyone in the control room can even react, the screen goes completely blank and the mysterious cosmic pulse is gone forever. If you love uncovering the deepest secrets buried across our universe with real science that keeps you thinking, hit that subscribe button right now. Joining this community means you will never miss a real cosmic mystery. To understand why a simple flash of invisible light can send shockwaves through the scientific world, we have to look at how we view the night sky. When you step outside on a clear night, the universe feels calm, quiet, and unchanging. You see bright white stars sitting frozen against a backdrop of deep black space. For thousands of years, humans believed that the sky was a peaceful blanket of quiet darkness. That peaceful idea changed forever when scientists learned how to listen to the cosmos instead of just looking at it. In the early 1930s, an engineer named Carl Jansky built a large wooden antenna to study static that was interfering with telephone calls. He expected to hear thunderstorm noise, but instead he picked up a steady hiss that moved across the sky every single day. He quickly realized that this strange noise was not coming from Earth at all, but from the center of our Milky Way galaxy. That surprising discovery marked the birth of radio astronomy. Scientists suddenly realized that visible light is only a tiny fraction of what is actually happening in space. The universe is actually bursting with invisible radio waves, gamma rays, and X-rays that tell stories our eyes could never see. Massive dishes were built all over the world to tune into these cosmic radio stations and map out the hidden structure of space. For decades, radio astronomers listened to the rhythmic, predictable music of the stars. They heard steady pulses from spinning dead stars called pulsars, which tick like atomic clocks across the galaxy. They mapped giant clouds of gas where new stars were being born. Everything in space seemed to follow neat, repeatable rules that scientists could study over and over again until they understood them completely. Then, without any warning, the universe started sending messages that broke every rule in the textbook. Astronomers began catching brief, ghostly signals that appeared once, flashed with unbelievable brightness, and then vanished into thin air. These phantom blips left behind no trail, no obvious origin, and no second chance for scientists to study them. Before Jansky made his discovery, most people thought space was completely silent and empty between the stars. An amateur astronomer named Grote Robert was so fascinated by Jansky's work that he built a giant metal dish right in his own backyard in Illinois. Robert spent years mapping the invisible radio sky while the rest of the world was asleep, proving that radio astronomy was a powerful new tool. Radio waves are actually just another form of light, but their wavelengths are much longer than the light our human eyes can detect. While visible light waves are tiny fractions of a millimeter, radio waves can be as short as a coin or as long as a skyscraper. Because radio waves pass right through thick cosmic dust clouds, they allow us to peer straight into the chaotic centers of distant galaxies. When you look at space through a radio telescope, the universe looks completely different than it does through an optical telescope. Quiet and dim objects like cold clouds of hydrogen gas glow brightly, while bright shining stars often fade into background noise. It turns out that the most energetic and violent events in the cosmos leave their biggest mark in radio waves. For a long time, researchers believed that all cosmic radio sources were continuous and steady, like a burning light bulb or a running engine. Stars and gas clouds emit steady radio streams for millions of years without changing very much from one century to the next. Even spinning neutron stars, known as pulsars, repeat their pulses every few milliseconds with perfect, unwavering clockwork precision. Scientists felt very comfortable with this predictable model of the universe because it made planning experiments easy. A researcher could point a telescope at a target, record data for a few hours, go home to sleep, and come back the next night to find the exact same source still glowing softly in the dark. That comfort was shattered when modern high-speed computers allowed astronomers to look at the sky in real-time, split-second snapshots. Did you know that astronomers spent over 40 years searching for the most famous mystery signal in history without ever hearing it again? Tell me in the comments if you think it was an alien beacon or just a natural glitch, and make sure to subscribe so you never miss another deep space story. The most famous of these ghostly events happened on a hot summer evening on August 15, 1977, at a giant radio telescope in Ohio nicknamed the Big Ear. A computer was quietly printing out rows of numbers that recorded radio signals from space. An astronomer named Jerry Amon was reviewing the computer printout a few days later when his eyes caught something that made his heart skip a beat. The computer had recorded a signal that was 30 times louder than the normal background noise of space. It was not a broad, noisy splash of radio waves like those made by hot gas or exploding stars. Instead, it was concentrated into a single, razor-thin frequency at 1420 megahertz, which happens to be the exact frequency where hydrogen atoms naturally vibrate. Scientists call this frequency the water hole because hydrogen is the most common element in the universe. Many astronomers had predicted that if intelligent extraterrestrial beings wanted to send a message across space, they would choose this exact frequency because any smart civilization would know it. The signal lasted for 72 full seconds, rising in strength and then fading away as the telescope swept across the sky. Jerry Amon was so stunned by what he saw on the paper that he took a red pen and circled the 6 characters representing the signal strength. Right next to the number 6 EQUJ5, he wrote a single word with an exclamation mark. Wow, that brief note became the name of the most famous unexplained radio signal in human history, known around the world as the wow signal. What scientists originally expected after that night was simple and logical. They expected the signal to repeat, or at least leave behind some kind of trace that another telescope could confirm. In science, a discovery is only considered proven if another team can look at the same spot in the sky and see the exact same thing again. What actually happened surprised everyone and frustrated astronomers for generations. Scientists immediately turned the big ear back toward that same patch of sky near a constellation called Sagittarius. They listened for days, then weeks, then months, but heard nothing except dead silence. Over the next 40 years, giant telescopes around the world pointed at those same coordinates hundreds of times, but the mysterious signal never returned. This massive gap between expectation and reality created a giant problem for researchers. A signal that only happens once cannot be easily tested, measured, or explained using standard scientific methods. It sits on the edge of science, forcing experts to wonder if they witnessed an alien greeting, a strange natural event, or just a ground-based human mistake that accidentally reflected off space debris. To figure out how the Big Ear recorded the signal, we have to look at how that unique telescope was built. Unlike traditional round dishes that tilt and rotate to follow targets, the Big Ear was a giant stationary structure as large as 3 football fields. It relied on the Earth's natural daily rotation to sweep its beam slowly across the sky from west to east. Because the telescope beam took 72 seconds to pass over any single spot in the sky, a real cosmic source had to follow a specific mathematical pattern. It had to grow stronger for 36 seconds as the telescope moved toward it, and then fade away for 36 seconds as the telescope moved past it. The wow signal followed this exact bell-shaped curve with absolute perfection. Even stranger was the fact that the Big Ear actually had 2 separate receiving horns side by side. As Earth turned, any real object in deep space should have triggered the first horn, and then 3 minutes later, it should have triggered the second horn. But the wow signal only appeared in one of the 2 horns, suggesting that it either turned on suddenly or turned off right after the first horn saw it. Over the years, scientists proposed dozens of natural theories to solve the mystery of the wow signal. Some researchers suggested that a passing comet surrounded by a huge cloud of hydrogen gas might have drifted in front of the telescope. Others argued that a classified military satellite or an illegal Earth-based radio transmitter had bounced off a piece of space junk floating in orbit. However, every single one of those natural explanations fell apart when tested against the hard data. Comets move too slowly and produce broad, diffuse signals, not narrow single-frequency pulses. Satellites move rapidly across the sky and leave clear tracks across multiple radio bands, which did not match the static coordinates recorded by the printer. When researchers checked astronomical databases, they discovered that there were no known satellites, planets, or asteroids in that exact line of sight during those crucial 72 seconds. The source of the wow signal remained completely blank, sitting in a dark region of space near a group of stars similar to our Sun. The mystery grew colder with each passing decade as technology improved, but the sky remained stubbornly silent. If you were a scientist who found a hidden signal buried in old files for 6 years, what would be your very first thought? Drop a comment below with your guess and hit the like button if you love solving cosmic cold cases. For 30 years, the wow signal stood alone as the ultimate cosmic mystery of a disappearing act. Many astronomers assumed it was just a one-time fluke, a weird coincidence that would probably never happen again with modern equipment. But in 2007, a professor named Duncan Lorimer and his student David Narkovich decided to dig through old archived computer files recorded by the Parkes Observatory in Australia. They were looking through data recorded back in 2001, searching for spinning stars when they noticed something entirely unexpected buried in the old records. It was a massive spike of radio energy that lasted for less than 5/1000ths of a second. Even though it was insanely brief, it was so powerful that it completely overloaded the telescope's sensitive detectors. This newly discovered flash became known as the Lorimer burst, and it opened up an entirely new chapter in astrophysics. It was the very first fast radio burst ever spotted by human eyes. In just a few milliseconds, this single burst had released as much pure energy as our sun creates over 3 entire days combined. Scientists were instantly divided over what this incredible discovery actually meant. Many researchers were deeply skeptical and argued that the signal could not possibly be coming from deep space. They believed it was far more likely to be a simple glitch in the telescope's software, or a flash of static from a lightning bolt on Earth, or even secret military radar equipment passing overhead. To make matters worse, astronomers at the Parkes Observatory soon began detecting dozens of other brief radio flashes that looked remarkably similar to the Lorimer burst. These strange flashes were named perytons, after a mythical creature that casts a human shadow. For several years, these perytons confused researchers because they seemed to happen mostly during daylight hours and appeared in multiple directions at once. The mystery of the perytons reached a hilarious and embarrassing climax in 2015. Researchers installed new monitoring equipment at the observatory to track down the exact source of these frustrating interference signals. After careful tracking, they finally caught the culprit red-handed. It was the kitchen microwave oven used by the observatory staff to heat up their lunches. Whenever a hungry scientist opened the microwave door before the timer reached zero, the magnetron tube inside spat out a tiny spark of radio waves. The massive telescope dish outside was so incredibly sensitive that it picked up that tiny microwave leakage and recorded it as a cosmic event. For a brief moment, it seemed like the search for mysterious disappearing signals from space had been defeated by a reheated burrito. However, the original Lorimer burst had one crucial feature that set it completely apart from microwave ovens and earthly interference. That feature is called dispersion, and it acts like a cosmic speedometer for radio waves traveling through the universe. When a radio signal travels across deep space, it has to pass through vast clouds of floating particles, dust, and thin gas. This interstellar dust acts like a giant glass prism for radio waves, slowing down lower frequencies more than higher frequencies. As a result, the high-pitched part of the radio wave arrives at Earth a tiny fraction of a second before the low-pitched part. By measuring how much the signal is stretched out across different frequencies, scientists can calculate exactly how far the signal has traveled before reaching our planet. When researchers measured the dispersion of the Lorimer burst, the math revealed something staggering. The signal had traveled through so much cosmic dust that it could not have originated anywhere inside our Milky Way galaxy. It had started its journey billions of light years away in a distant galaxy far beyond our own neighborhood of stars. And to put a billion light years into perspective, consider that light travels at 186,000 miles every single second. In 1 year, light travels nearly 6 trillion miles through empty space. That means the Lorimer burst left its home galaxy long before Earth's first multicelled animals ever evolved, traveling across the vast void of space for billions of years just to hit a dish in Australia for 5 milliseconds. Have you ever wondered how many invisible signals from billions of light years away are passing through your room right now? Tell me what you think in the comments, and don't forget to subscribe to stay updated on the newest space discoveries. This realization changed everything overnight. Scientists realized that fast radio bursts were real, incredibly powerful, and happening all over the sky every single day. The only reason we had not noticed them before was that our radio telescopes were not fast enough or wide enough to catch a flash that lasts only a few milliseconds. What scientists expected to find as they built bigger and faster sky-scanning telescopes was a simple single cause for these deep space blasts. They hoped that once they detected enough of these bursts, they would quickly see a neat pattern pointing directly to a specific type of exploding star or cosmic collision. Instead, the reality turned out to be far more complex and mysterious. When telescopes like the Canadian Hydrogen Intensity Mapping Experiment, also known as CHIME, began scanning the sky, they started finding thousands of these fleeting radio bursts. Some of these signals were one-off events that flashed once and vanished forever, while a small handful of others actually repeated on regular schedules. This created a major puzzle for astrophysicists around the globe. How could two signals that look almost identical on a computer screen behave so completely differently in reality? A signal that repeats means the object producing it survived the event, ruling out a massive explosion that destroys a star. But a signal that never repeats might come from a catastrophic event like two dense dead stars crashing together and collapsing into a black hole. The CHIME telescope in Canada is a revolutionary instrument designed specifically to solve this exact mystery. Unlike a traditional round dish that points at one small patch of sky, CHIME looks like 4 massive half-pipe snow ramps made of wire mesh sitting in the mountains of British Columbia. It has no moving parts at all, using powerful custom supercomputers to digitize and monitor the entire northern sky every single day. Because CHIME observes huge swaths of space all at once, it expanded our collection of known fast radio bursts from a few dozen to several thousand in just a few short years. With this massive mountain of new data, astronomers discovered that repeating bursts are surprisingly rare, making up less than 3% of all detected signals. The vast majority are true ghosts that flash once and disappear forever into the dark. One of the most famous repeating signals is known as FRB 121102, which was first spotted by the giant Arecibo Observatory in Puerto Rico. Unlike the Lorimer burst, this signal fired off dozens of intense radio bursts over several years. Scientists were able to use a network of linked radio dishes across the world to pinpoint its home to a tiny dwarf galaxy located 3 billion light years away from Earth. By studying the host galaxy of FRB 121102, researchers discovered that the signal was coming from a region filled with intense magnetic fields and dense stellar gas. This environment suggested that the source was sitting right next to a supermassive black hole or buried inside the turbulent remains of a recent supernova explosion. It was a huge step forward, but it raised new questions about whether non-repeating signals shared the same origin. While scientists were busy trying to map out distant galaxies to solve the radio burst puzzle, another terrifyingly close signal appeared much closer to home. In April and May of 2019, astronomers used the famous Parkes dish in Australia to study Proxima Centauri. Proxima Centauri is a small red dwarf star that happens to be our closest neighboring star system, located just 4.2 light years away from Earth. This red dwarf star is particularly interesting to scientists because it has at least 2 planets orbiting it. One of those planets, named Proxima Centauri b, is roughly the same size as Earth and sits in the habitable zone where temperatures might allow liquid water to exist on its surface. Because it is our nearest neighbor, SETI researchers frequently point telescopes toward it to check for signs of advanced technology. In 2020, a young university student named Shane Smith was carefully going through 26 hours of archived data collected during that Proxima Centauri study. He was using advanced computer algorithms designed to filter out the millions of human radio signals that constantly clog up Earth's atmosphere, such as cell phones, satellites, television broadcasts, and airplane radar. As the software ran, it flagged a specific signal that was recorded on April 29, 2019. The signal was given the official name BLC1, which stands for Breakthrough Listen Candidate 1. It was a sharp, narrowband radio signal centered at 982 megahertz, a frequency that is almost never used by normal human telecommunications or natural space phenomena. If you found out that a strange radio signal was coming from the closest star system to Earth, how excited or nervous would you be? Drop your thoughts in the comments below and hit the subscribe button if you want to follow every step of this ongoing search. The discovery of BLC1 immediately set off alarm bells throughout the astronomical community. For the first time in over 40 years, scientists had detected a radio signal that passed nearly every single initial test used to identify potential alien technology. It was extremely narrow in frequency, meaning all its energy was packed into one tight spot, which is a classic signature of artificial transmitters. Even more compelling was the way the signal behaved as the telescope moved. When the giant Australian dish pointed directly at Proxima Centauri, the 982 megahertz signal appeared loud and clear. When the operators turned the dish away to look at a different patch of sky, the signal vanished instantly. When they turned the dish back to Proxima Centauri, the signal returned right on cue. This off-pointing test is the gold standard for radio astronomy because it strongly suggests that the source of the signal is a specific point in space, rather than local interference sitting on the ground nearby. Over the course of 5 hours, the signal appeared 5 separate times, drifting slowly in frequency just as you would expect if it were coming from a moving planet orbiting another star. For nearly a full year, a team of top international scientists worked in total secrecy to investigate BLC1. They tested every theoretical explanation they could imagine, analyzing satellite orbital tracks, checking secret military communication databases, and searching for aircraft pathways. The stakes were impossibly high because announcing an artificial signal from our nearest star system would be the biggest scientific story in human history. What the public and many researchers expected was a grand announcement that we had finally found our neighbors, or at least a confirmed space mystery that could not be explained by modern technology. People held their breath as the final scientific papers were prepared for release in late 2021. The actual reveal was both a triumph of careful science and a quiet disappointment for alien hunters. In October 2021, the research team published their final findings, proving that BLC1 was not an alien message after all. Instead, it was an incredibly complex case of human radio interference created right here on Earth by overlapping electronic devices. Scientists discovered that 2 pieces of ground-based electronic equipment, likely located near the observatory itself, were emitting weak radio signals that mixed together inside the receiver's electronics. This mixing process created a phantom frequency at 982 megahertz that accidentally mimicked an interstellar signal. Because the interference occurred only at certain times when the telescope was moving, it tricked the automated filters into thinking it came from space. To understand how 2 everyday signals can merge to create a phantom signal, think of sound waves from 2 musical instruments. If 2 musicians play different notes at the same time, your ear hears a third pulsating sound created by the way the sound waves interfere with each other. Electronic receivers experience the exact same effect, known as intermodulation, when powerful signals hit their internal amplifiers simultaneously. In the case of BLC1, the telescope was picking up ordinary clock signals from digital hardware located nearby on the ground. When combined with oscillator drift inside the signal processor, it produced a fake mathematical signature that happened to match the exact mathematical pattern expected from an orbiting alien planet. It was an incredible reminder of how easy it is for human technology to trick even the smartest scientists. Even though BLC-1 turned out to be an earthly ghost, the hunt for real disappearing signals from the cosmos was far from over. In fact, right around the same time BLC-1 was being solved, astronomers caught a vanishing signal that was so powerful and close that it changed our understanding of the universe forever. On April 28, 2020, 2 independent radio observatories in North America picked up an impossibly bright flash of radio waves that lasted for only 1 millisecond. Unlike the Lorimer burst, which came from billions of light years away, this new signal came from right inside our own Milky Way galaxy, just 30,000 light years from Earth. This signal was so strong that it could have been detected by a simple radio receiver in your pocket if you were tuned to the right frequency. For the very first time, scientists were able to track the exact source of an active fast radio burst back to a known object in space. The source was an extraordinary dead star known as a magnetar, carrying the formal name SGR 1935 plus 2154. A magnetar is a special type of superdense neutron star that has an ultra-powerful magnetic field. A single teaspoon of material from a magnetar would weigh as much as a mountain on Earth, and its magnetic field is trillions of times stronger than the magnetic field of our planet. If a magnetar were located halfway to the moon, it would instantly wipe clean every credit card strip on Earth and tear the atoms inside your body apart. Scientists realize that when the hypercompressed crust of a magnetar cracks under intense magnetic stress, it triggers a massive starquake. And this sudden starquake releases an overwhelming blast of magnetic energy and high-energy particles, creating a blinding flash of radio waves that shoots across the galaxy before vanishing into the dark. When a magnetar undergoes a starquake, the physical forces involved are hard for the human mind to process. The star itself is only about 12 miles wide, roughly the size of a small city, but it packs more mass than our entire sun into that tiny sphere. The outer crust is made of compressed iron that is thousands of times stronger than steel, held under unbelievable gravitational pressure. When the tangled magnetic lines snaps beneath the surface, the crust shifts by less than a fraction of an inch. That microscopic shift releases more kinetic and magnetic energy than 1 billion nuclear bombs exploding all at once. The resulting shockwave rips through the surrounding plasma, accelerating charged particles to nearly the speed of light and blasting out a radio pulse that travels across thousands of light years. This galactic discovery solved a massive chunk of the cosmic puzzle, proving beyond any doubt that magnetars are definitely responsible for at least some of the mysterious disappearing radio bursts we detect from deep space. But just as scientists began celebrating this giant breakthrough, new observations revealed that magnetars cannot explain every single vanishing signal we see. Some disappearing signals behave in ways that completely defy the magnetar theory. For example, in 2018, astronomers detected a signal named FRB 180916 that flashes on a super strict clockwork schedule. It fires off brief radio bursts for 4 straight days, goes completely silent for 12 days, and then repeats the exact same 16-day cycle over and over again with unbelievable precision. Other signals flash once with unimaginable energy far brighter than any magnetar could ever produce, and then never utter a single peep again despite years of continuous monitoring. Scientists are now forced to face a fascinating reality. There is not just one type of vanishing signal in space, but several completely different cosmic phenomena that we are only beginning to understand. For instance, in 2021, astronomers traced a repeating radio burst back to a globular cluster located in a nearby spiral galaxy called Messier 81. Globular clusters are ancient groups of extremely old stars where no young magnetars should exist. According to standard star evolution models, magnetars only form when giant young stars explode as supernovas, leaving behind a magnetic core. Finding an FRB in an ancient graveyard of stars proved that nature has multiple ways of generating these extreme bursts. One theory suggests that in dense star clusters, 2 white dwarf stars can slowly spiral into each other and merge, forming a fresh magnetar long after normal star formation has stopped. Another theory proposes that colliding neutron stars or exotic black hole interactions might be generating these bursts without leaving behind any long-lived remnant at all. Scientists have also discovered that fast radio bursts can be used as cosmic light bulbs to solve other major astronomical problems. For decades, scientists faced the missing baryon problem, where cosmological models predicted twice as much normal matter in the universe as astronomers could actually see through normal telescopes. Half of all atoms in the universe seem to be completely missing. By measuring the dispersion of thousands of distant fast radio bursts as they traveled through intergalactic space, researchers were able to weigh the invisible gas floating in the vast voids between galaxies. The radio waves slowed down by just the right amount to account for every single missing atom. In solving the mystery of the disappearing signals, scientists accidentally solved the mystery of the universe's missing matter. Right now, as you listen to these words, the universe around us is flashing with thousands of these brief high-energy events every single day. Most of them pass right through our planet without anyone noticing, passing through our homes, our air, and our bodies like invisible ghosts in the night. We are living inside an energetic, noisy cosmic furnace that we are only just learning how to tune into. To catch these fleeting events before they vanish forever, humanity is currently building the most impressive scientific tools ever conceived. In the remote deserts of Australia and South Africa, construction is underway on the square-kilometer array known as the SKA. This giant project will combine thousands of individual radio dishes and low-frequency antennas spread across 2 continents to create a single giant telescope with unprecedented sensitivity. When fully operational, the SKA will be able to scan huge areas of the sky simultaneously in real time. It will process more data every single second than the entire global internet uses today, using supercomputers to catch, analyze, and map thousands of disappearing signals the exact moment they flash across space. In addition to the SKA, China has built the FAST telescope, a single massive dish suspended in a natural mountain basin that measures 500 meters across. FAST is so sensitive that it can pick up extremely faint radio whispers that were completely invisible to older observatories. It has already discovered hundreds of new pulsars and dozens of quiet, fast radio bursts that were previously hidden in background noise. Advanced artificial intelligence systems are also revolutionizing how we analyze radio data. In the past, scientists had to spend months manually sorting through gigabytes of recorded noise to spot brief anomalies, often missing crucial split-second events buried in technical artifacts. Today, deep learning algorithms process raw data streams in real time, identifying potential space signals in microseconds and instantly alerting other telescopes around the world to pivot and look at the exact same spot. These new telescopes will finally allow us to answer the questions that have haunted astronomers since Jerry Amon wrote "Wow" on his computer printout back in 1977. We will finally find out whether one-off signals are the final gasps of dying stars, the violent births of new black holes, or perhaps the distant beacons of advanced civilizations calling out across the dark. The story of the hidden signal that vanished as fast as it appeared is ultimately a story about human curiosity and our relentless drive to understand the unknown. It reminds us that science is not a finished book full of simple answers, but a living, breathing detective story where every closed case reveals 10 new mysteries waiting to be solved. Every time we point a giant dish toward the stars and catch a brief unexplained flash of light, we are reminded of how small our planet really is in the grand scheme of the cosmos. We are sitting on a tiny blue marble floating through an endless sea of invisible energy, listening intently to the quiet dark and daring to ask what else is out there waiting to be found. As technology advances, our ability to hear the quietest whispers of the universe improves exponentially. In the coming decades, space-based radio observatories built on the far side of the moon will shield our instruments from all human noise, opening up an entirely silent window onto the cosmic microwave background and the earliest moments of creation. When we look up at the night sky, we are not just looking at cold stars frozen in time. We are looking at a dynamic, ever-changing ocean where monster cosmic engines are firing off pulses of immense power, sending light on journeys across billions of light years to reach our small world. The signals that vanish in milliseconds are reminding us that the sky is alive with action every single moment. Whether these signals turn out to be exploding magnetars, colliding black holes, or structural beams powering alien light sails, each discovery brings us one step closer to understanding our place in the cosmic story. The hunt for these vanishing ghosts of deep space proves that the universe is far stranger, far more chaotic, and far more beautiful than we ever dared to dream. If you enjoyed exploring these mysterious space signals today, click that subscribe button right now and turn on all notifications so you never miss a new discovery. What do you think is the true cause behind the non-repeating fast radio bursts in deep space? Drop your thoughts in the comments below and share this video with a friend who loves cosmic mysteries as much as you do. Thank you so much for watching, and keep looking up at the stars.